Hi, Assalamualaikum. My name is Ngazima, binti Salim. My metric number MA18264. So I will present for Lab 4 pump configuration for Chapter 1. So this laboratory experiment shows that three types of setup for determining the characteristic of the pumps. It demonstrates the volume flow rate, pressure of the pump, net head and water horsepower as characteristics of the pumps. The finding of the experiment shows that each setup experiences different pressure at the suction of the pump. The laboratory report discusses on how the experiment was conducted for different types of setup. Other relevant information will be further demonstrated on the result and discussion. So, introduction and for the background for this lab is pumps are usually located at the source to increase the water level and at the intermediate points to improve the water pressure in waterworks and wastewater systems. A pumping station's components and architecture are critical to its performance. Centrifugal pumps are commonly used in water and wastewater systems, so understanding how they function and how to build them is critical. Centrifugal pumps have a lot of advantages over other pump types, including the simplicity of design or construction, which is no valve and no piston rings, high efficiency, ability to work against a variable head, suitable for being powered by high-speed prime movers such as turbines, electric motors, internal combustion engines, and other high-speed prime movers, and there is continuous discharge. A centrifugal pump is made up of a spinning shaft and an impeller, which is usually made up of curved plates. The impeller spins inside its shell, sucking the fluid through the casing's eye, which is in this point, at the point 1. The fluid's kinetic energy rises as a result of the impeller's added energy, and it reaches the casing discharge end, which has expanding region, which is this point, and as a result, the pressure inside the fluid rises. So, figure 2 depicts the efficiency of a centrifugal pump, a schematic curve, which is pumping head versus discharge, brake horsepower, which is input power versus discharge, and efficiency versus discharge. So, the manufacturers have seen a chief curve for industrial pumps. To generate such curve, a pump should be tested in the laboratory under various discharge and head conditions. Additional pumps in series or parallel with the original pump might be considered if a single pump is incapable of achieving the design flow rate and the pressure. Pump characteristic curves, whether in series or parallel, should be built because this knowledge aids engineers in determining the types of pumps required and how they should be designed. So, problem statement for this lab is during the experiment is to overcome the pressure loss caused by the friction of valve, pipes and pipe system fittings. It is important to choose the pump that best suits the needs of the project. And objective of this experiment is to determine the performance characteristic of two centrifugal pumps configured as a single pump, two pumps in series, and two pumps in parallel. Scope of the experiment: each configuration pump is a single pump, two pumps in series, and two pumps in parallel will be tested at the suction pump pressure of -63, -61.8, and -61.5 kilopascal. A time water collection will be conducted to determine the flow rate for each test and obtain load, hydraulic, and overall efficiency ratings.
Assalamualaikum and salam sejahtera. My name is Mohammed SahrulFahmi with Senan, and I will present about the literature review. Okay, a pump is a mechanical device that propels fluids or occasionally slurries by converting electrical energy to hydraulic energy. Pumps are grouped into two categories, which is positive displacement pump and dynamic pressure pump. Okay, mechanical pumps are used in a variety of applications, including pumping water from wells, aquarium filtering, and pond filtering. Okay, next I will explain about the dynamic pressure pump. The example of dynamic pressure pump is a centrifugal pump. The centrifugal force is used in dynamic pump to create a velocity in the liquid being handled. Next, the centrifugal pump is a mechanical device that uses rotational energy to move a fluid through the use of one or more driven rotors, referred to as impeller. Okay, the fluid enters the quickly rotating impeller along its axis and is sucked out along its circumference by centrifugal force via the impeller. The impeller increases the velocity and pressure of the fluid and also goes it toward the pump exit. Finally, the pump casing is built specifically to compress the fluid entering the pump, direct it into the impeller, and then slow and control the fluid before discharge. This is the figure for the centrifugal pump. Okay, the outlet area will be bigger because the velocity is low here and the pressure will be higher at the outlet. Alright, next I will explain about the positive displacement pump. The example of a positive displacement pump is a gear pump. The positive displacement pump moves a fluid by predically enclosing and mechanically moving a fixed volume. It circulates a fluid by predically confining it in defined container with interlocking cords or gear and mechanically transfer it via cyclic pumping motion. Gear pump uses the action of rotating cords or gear to transfer fluid. The rotating element develops a liquid seal with the pump casing and creates suction at the pump intake. Fluid drawn into the pump is enclosed within the cavities of its rotating gears and transferred to the discharge. This is a figure for the gear pump. You can see here. There is the external gear pump and the internal gear pump. The pump will compress the fluid and flow the fluid to the other side. Okay, this is my final presentation. We have a series and a parallel for the pump circuit. In the left side, we can see the figure for the series. When the pump is connecting in series, the total head created is double. This is a H total is plus with H1 from pump 1 and H2 from pump 2. With the same flow rate, the head will be double. Okay, for the parallel, when the pump is connected in parallel, the head rated is equal. This is the H total equal to H1 plus equal to H2, and the flow rate will be increased. Okay, that's all for my part.
Assalamualaikum and good day to my fellow lecturers. My name is Mohammed Norzani, MA18261, and today I'll be covering the Chapter 3 Methodology project. For starters, we have three kinds of setup that we're going to use. The first one is the single pump configuration. The next one is the parallel pump. Last but not least is the single pump configuration. Before we proceed further with the experiment, here are some safety steps that we should follow when we are proceeding with the laboratory experiment. First and foremost is to wear a footwear that fully covers your entire foot. Secondly is the power switch. Ensure the switch is turned off before we proceed with the experiment, and after we've done using the machine, we may proceed to turn off the switch before leaving the laboratory. The third one is to follow the instruction accordingly for the lecturer or laboratory assistant. Should we facing a problem, refer to the authority in case of emergency. Last but not least is to wear a proper attire. You may wear your laboratory coat or faculty jacket inside the laboratory at all times. For the first setup, which is a single pump configuration, there are 4 steps. The first step is to close the third valve by turning it to the right. The next one is to close the second valve. The third one is to close the fourth valve. Last but not least is to turn on the pump to single pump by switching it to the left. Then you may adjust the output valve to your desired volume. Next is the parallel pump configuration. There are only two steps in this setup. The first step is to close the third valve by turning it to the right again. Then proceed to close the second valve at the back of the pump configuration. Afterwards, which is the last step, is to switch on the pump by turning it to the right. Now onwards to the last setup, which is the series pump configuration. There are three steps involved. So onwards to the last configuration, which is the series pump. First step is to close the second valve located at the back end of the pump configuration. The next step is to close the fifth valve located at the front of the pump configuration. Last step is to switch on both pumps by turning it to the right.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Abdulaziz. Today I'm going to explain the result part, which is about the three different pumps. In this experiment, multiple pump configurations are examined to evaluate the pump performance, which is the efficiency of each pump, and we compared them by the head loss and the performance of them, depending on which of these three settings is up. Okay, the first of all, which is about the single pump, as shown here, the pressure and the volume flow rate, which is B given, and we use that the power consumption, which is 660. We have to figure out the net head and the horsepower and the efficiency. We have found out the net head, which is increased from the the first step of the volume flow rate until the last one, which is some increasing in the number until we reach the 7 row. Okay, and the overall efficiency, when we start from the beginning of the volume flow rate, which is 0.0037395, here the efficiency we have found out it's 14.067. Here it is will go to the through one, it will be some decreasing in the efficiency until when we saw that the efficiency it's low and the head loss it's high. This is for the single pump configuration. The second one, which is series pump configuration, we use at the same procedures, but in this time the efficiency also in the first one 30, then increased by until we reach the volume flow rate, which is 0.004444. Here the performance is increasing until we reach here the efficiency was 41.08 and the volume flow rate was we taken 0.0037895. Then will be suddenly decreased. This is for the series pump configuration. Okay, the third part, which is the parallel pump configuration, we use the same procedures, and we have to figure out the horsepower by we take the pressure delivered 1 and by the pressure delivered 2, we divided them by the density and the gravity, and we get this number, which is 229.59. Will be the same for the rest of the experiment or of the flow. We go to the graphs which was generated. It is the graph flow rate against pump. Here the head flow rate and the flow rate for the single part. We have that when we see that the the number of the head bump which is decreased, we start from the beginning until we reach the last point. We see that the decreasing in the number. We go to the next one, and this is for the series part, which we realize that the series part we have here is decreasing in the number between the pump head and the flow rate. And the last part, the comparison between the three pump, the single, series, and parallel. Okay, which is so that the graph compares between the pump output curves of three different pumps configuration, which we have mentioned that before: single, series, and parallel. All the three different pumps configuration have a relationship pattern toward flow rate and pump head. The series pump show the highest pump and head compared to the others, while the single pump head show the lowest pump head, since the pump head is obtained by increasing to single head at the same flow rate. The head in the series pump configuration is greater. As a result, we've found that the similar pumps in series is twice that of the single pump at the same flow rate. The flow rate value for parallel pump configuration is the highest as compared to the others, and the series pump had the lowest flow rate. From this observation, which leads us to conclude that when two pumps are connecting in parallel, the resulting output curves obtained by adding their flow rate at the same head when two similar pumps are connecting. This is all from me, which is about the result part. Thank you so much.
Hello, my name is Yu Jing MA18261. Now I will be present the discussions from the leg 4, which is the series and parallel pumps. Okay, as you can see, this is the graph from the flow rate against the pump head from the single pump configurations. From the single pump configurations, the formula of neck head for the single pump, which is pressure over rho G, which the rho is equal to thousands and G is equal to 9.81. So as you can see that as the flow rate increase, the lower the net head. So we can deduct that the pump head is inversely proportional to the flow rate. So the flow rate and the pump head is directly proportional to the power output. So we increase the flow rate and the pump head will increase the power output of the pumps. So in the series pump configurations, it has the highest pump head. So for the graph of the flow rate against the pump head in the series pump configurations, the formula of the net head total for the series pump, which is head 1 plus head 2. So the inverse horsepower for the series pump, which is 0.66 kilowatts by 12, is because the pump is in series configuration, so we need types 2. So as you can see, the series identical pump can produce twice the head of a single pump at the same flow rate. So as the flow rate increase, so the pump head will decrease. So in the series pump, the relationship state that the pump head is inversely proportional to the flow rate. So as the flow rate rise, the productivity also will increase. Then efficiency can be said to directly proportional to the flow rate. So from the graph of the flow rate against the pump head in the parallel configurations, the net head of the parallel pump configurations equals to net head total equals to H1 plus H2 divided by 2 because it's in the parallel configurations. So we need to divide by 2. So as the flow rate increase, the pump head will decrease. So as the two identical pumps are connected in the parallel, so flow rate will be double, while the head is stayed constant. So for the parallel pump, the pump head is inversely proportional to the flow rate. In the parallel pump configuration, the flow rate value is the highest compared to the others. So it is because it is capable to produce twice the flow rate while putting the less pressure on the pump. So we also can say the exhaust power is lower in the parallel pumps, which means that the efficiency is higher compared to the other pumps. So in a nutshell, from this experiment, we are able to learn that the principle of the operating characteristic of the centrifugal pump in configuration of the series, parallel, and single pumps. We also can able to plot and determine the pump characteristic curve of pump to determine the pump power. We also know that the flow rate increase will increase the efficiency. So from the result we determine from the experiment, we know that the efficiency of a single pump reaches 14%, while the series pump is 15% and parallel pump is the 17%, which means that parallel pump has a more power output in centrifugal pump.